Hi, my name is Greg Littlefield. I'm an engineer at Workiva, and today I'm going to be talking about getting the most out of React and Dart. So for this presentation, first I'm going to go over a little bit of background around Workiva's use of React and Dart, and probably answer the question that most of you have, why React and Dart? Then I'm going to give a quick intro to React to help those of you not familiar with React to get your feet wet a little bit and understand the concepts I'll be going over. Then I'm going to go over the initial frustrations that we encountered when we first started using React and Dart. And finally, the good stuff, solving those issues and alleviating those frustrations using our new library that we've called Overreact. Great name. Thank our PM for that. So first, background. At Workiva, our first application was actually written in Flash back in 2008, and eventually we migrated to writing our newer applications and new features in HTML5. We started with Angular 1.0 and jQuery, and then we eventually made our way to React. And we really liked React. We liked the declarative nature of rendering views. We liked the unidirectional data flow, and we started writing a lot of UI in React. And then we stumbled upon Dart, and we really liked the powerful developer tools, how fast we could develop with it. And we really wanted to put the two together and get the best of both worlds and be able to continue taking advantage of all of the existing React code that we had written. So we decided to use React and Dart together. And so a little bit of context on me. So I'm on the UI platform team at Workiva, and we're tasked with supporting a number of product teams alongside some other platform teams and creating reusable UI components for all those product teams to use. So when we first started writing React and Dart, we found it kind of cumbersome. And so a lot of the stuff that I'll be talking about today, like Overreact, is the result of us improving that workflow and building upon that. So now a quick intro on React. Quick show of hands, how many of you have used React or are familiar with the basic tenets of it? Okay, so we got some, not everyone, so that's cool. Glad I have this section. So React is centered around components, and there's DOM components and custom components. You can see this is a JSX representation of it. That's probably one of the more popular syntaxes to consume React components. You can see for DOM components, it looks pretty similar to standard HTML. You're passing in attributes or key value pairs, and then you're nesting components within each other. For custom components, it pretty much looks the same way. You can nest components within each other, and you can specify data by passing in these key value pairs that look like attributes. And then eventually, both forms eventually render as HTML. DOM components get translated directly, and then custom components get translated into virtual DOM, and then into rendered HTML. So again, a custom component encapsulates virtual DOM rendering, and it can also include UI behavior. You can bind event handlers and do other things in it. And then the data that's passed into components in React is referred to as props, and that's represented as key value pairs or a map, and that data is immutable to the component. So that can only be updated when whatever is rendering it re-renders it, and the component doesn't really have a say in updating that data. So that's very core to the React unidirectional data flow mental model. Then components can also have state. This is another kind of data that a component uses. It's maintained by the component itself, though. So the component itself can mutate that data and manage it in response to either user input or server calls or other external things. And then together, ideally, only props and state make up the rendered output of components. So pure components, really idiomatic React components, are only going to use props and state in their render method, which generates that virtual DOM, which then gets passed to React. And so I talked about render. Render is one of the many lifecycle methods in React, and it's actually the only required lifecycle method. There's a whole bunch of other ones relating to the component bootstrapping or mounting and then receiving new data. And I'm not really going to get into those. All we're going to worry about is render. So now let's talk about our initial frustrations. Now that we know how React works, we can kind of understand why these things were frustrating. So at Workiva, when we first started using React and Dart, we used this library called React Dart on Puppet's React, and this is a wrapper on top of the React JavaScript library. And what this wrapper does is it proxies lifecycle methods in React JavaScript code and exposes them via Dart API. So you can write actual React JavaScript components with a Dart API, and it's all backed by the React JavaScript library. And so this is how you would consume a component in Dart using React Dart. And you can see it has the same basic structure as the JSX. You're specifying data as key value pairs, and you're nesting components. But we don't have that JSX syntax. And actually, you can do the same thing in JavaScript. If you don't want to transpile your code from JSX to JavaScript, you can just use those component factories directly, invoke them, pass in the map of data, and then nest the components inside. So React Dart actually looks really similar to React.js, and using them is very similar. One thing to point out, though, is that in React.js, you can specify props using identifiers. You can use identifiers as the keys in maps, because in JavaScript, there's sort of a duality between properties and key value pairs. Maps and objects are really the same thing. In Dart, that's not the case. So in order to best represent props and parity behavior of being able to merge different props maps together and be able to forward certain props and not others, React Dart went with map to best represent that data structure. And I think that was a good call. But just know that in React Dart, you do have to use string keys, whereas in JavaScript, you could use string keys, but you could just use an identifier instead. And so the problem with that is that we can't get great static analysis on these key value pairs. I mean, we can get static analysis, and that'll tell us if we did something syntactically correct or incorrect. But if we do something semantically incorrect, then it's not really going to tell us ahead of time. And so what does that mean? So here's some examples of that. First, I've got a custom button component, and I want to make it green. So I'm going to set the color prop on it and pass in the green skin, and it's not green. So maybe I forgot the API, or I misremembered it, but color isn't the right prop to make the button green, to set that skin. And since color is not used by the component, it's just going to get ignored and kind of pass through as like an extraneous prop. And so if you set that prop, you're not really going to get an indication of why it's not working. You're just going to know that it's not working. And so like in this case, we would have wanted to use the skin prop, and then that works correctly. A similar error is if you mistype the skin prop. You could have a typo in that string key, and it wouldn't give you an indication that it was wrong, and you'd think that you did it right, but it just won't work. So that can also be frustrating, that you don't get typo checking. Another issue you can run into is if your prop is of the wrong type. So in this case, we have a button, and we want to wire up an on-click handler so that when we click it, it prints a message to the console. And when we render that, it actually works. But when we go to click on it, we get a type error. The on-click handler expects to have one argument. It passes through the event. And so when we give it a function that doesn't take any arguments, when Dart invokes that, we get this error. And so to resolve that, we would add a event as a parameter to that method. So that's a case where even after you run and bootstrap your app, you still won't know that it's wrong. You have to go and actually click the button to figure out that you made a mistake, which is not a great development experience. And then similarly, inside of a component, when you're rendering the encapsulated virtual DOM, you have to use those string keys to access those props. And so what we ended up doing, just kind of as a de facto standard inside Workiva, is we would proxy these key value pairs with these getters that we'd defined in the component. So we'd be able to get a little bit of static analysis and strong typing inside the component, but we still didn't have that when we were consuming the component. And we also still ran the risk of mismatching this skin key or mismatching it with the key that the consumer is actually using to render it. Then we also started doing that with state, and we ended up with all these getters at the top of our component. And it was really hard to tell what data was coming from state and what data was coming from props. And so that made it really hard to reason about the data flow within the component, and it just made unreadable components. And then similarly with state, we had to use those key value pairs or those string keys, and that wasn't ideal. So we thought, this could be Dartier. So what we came up with is a library called Overreact. So Overreact is a layer that sits atop of React Dart and React and better adapts the API for use in Dart. And it just makes it easier to use React and Dart. One of the big things that it provides is statically declared React UI components. You can declare your props and state in a static way and get analysis support for those. It was built with reusability in mind. Again, I'm on the UI platform team, and a lot of what we were doing was building reusability or reusable components. So we kind of baked in some features to make that easier on ourselves, and we think that'll help others make reusable components too. It's also production ready. It's been used in a number, or it's being used in a number of Workiva apps in production and has been for a while. So we're pretty confident in its stability. And it's also open source, and we just released it, I think, like a couple of days ago. So we're really excited to get it out there. And here's a link to this great site our team lead put together. And I'll have a link to that at the end of the slideshow too. But yeah, definitely check out those docs. So before I get into the details, I really want to just communicate some of the design decisions that guided us while we were building this library. First, we wanted to utilize Dart Analyzer to its full potential. As you saw, those issues that you can run into when you're using string keys can be super frustrating when developing, and we weren't getting the most out of the great Dart tooling that was available to us, so we wanted to make sure we did that. Second, we wanted to preserve React principles and patterns. We didn't want to create a whole new framework. We didn't want to diverge from React. We just wanted to take React and make it easier to use in Dart. So that way, we can take advantage of all of React's community, all of its existing documentations and blog posts and libraries and all of its upcoming developments and new features. And finally, we wanted to keep the workflow fast and simple. We didn't want a lot of boilerplate. We wanted to keep declaring components simple and easy, and yeah. And so we've seen the syntax of JSX, and we've seen the syntax of React Dart. Now here is the syntax of Overreact. So you can see it has the same basic structure where you're nesting components within each other, and you're specifying these key value pairs, but it looks quite a bit different. So let's focus in on this one specific example, break it down, and see what's actually going on here. So first, what happens when I'm consuming this custom button component is I invoke the button function to create a new builder. And then on this builder, I can use these type setters to add prop key value pairs. In this case, I'm setting the ID prop to the demo button value. And I can cascade these using Dart's ... syntax to add as many props as I want, all inline. And then finally, I wrap up that expression of that builder, and then I invoke it with the children I want to nest inside that component, and then that returns a virtual DOM instance of my button. And that's it. So the first thing about this syntax is that it's such a joy to work with in an IDE compared to the old string key method. So first, if you try and use a prop that's not available, you're going to get a static analysis error saying that that prop isn't declared. And if you go to fix it, you will actually get an autocomplete list of all the props that are available along with the doc comments. And so that makes your APIs a lot more discoverable. A lot of developers don't tend to learn better by just exploring the APIs instead of reading a bunch of docs. So this makes that a lot easier. Then you can also optionally type these props, these setters. So in this case, we get an error saying that this function has one too many arguments, so we can just go and add that and not have to wait until we click our button to figure out that there's a problem with it. And so this Fluent interface, we saw it for custom components. It's also available for all of the DOM components corresponding to all of the DOM elements. In this case, we have a text area, and we're setting some DOM attribute props on it. And so we have all the DOM components that are available in React Dart and in React. And then we also have all of the DOM props that you can set on a DOM component. And so I can't remember all of these, especially the weird camel casing that some of them have, like tab index is camel case when it's not an HTML attribute. I can't remember that. So having the autocomplete is really valuable to make sure you're not mistyping something. And so like I showed before, this works with custom components, but something I wanted to call out is what we call ubiquitous DOM props. So what we found when we were building, when my team was building all of these custom components, is there were a set of DOM props that consumers wanted to add to our components like all the time. Like they wanted to set a custom ID or bind some custom event handler. And so what we ended up doing is baked into the base builder class, we have props like ID, tab index, title, style, class name, as well as all of the event handlers declared on that builder so that when you're declaring a custom component, all you have to do is pass through all of the unconsumed props to your rendered DOM component, and then you'll just get all those props passing through for free. You don't really have to redeclare them. And so that makes your components a bit more reusable. And so we've seen these type setters in action, but how do they actually work? So the idea behind this is to take a map view class, which is a Dart class that wraps around a map and implements the map interface. So you can use it wherever a map can be used, but you can also tack on additional functionality. So in this case, we've added type getters and setters that proxy these key value pairs in props and state. So when we set the setter, it adds that key value pair. When we access the getter, it reads it. So we initially were doing this by hand, and it proved to be kind of tedious. We could still mistype things, and yeah, it was a pain. So of course, we went to code generation to do that for us. Right now via pub transformer, but I could see it being a Bazel build step eventually. But to declare a prop, a statically declared prop, you just declare a field, and then the transformer synthesizes that to getters and setters. And because most of the use cases, or all of the use cases of the props, in all of the use cases of the props, fields behave the same way as getters and setters do to the Dart analyzer. So we're actually able to analyze the pre-transformed code and get analysis on this and not have to run the generation step and analyze that to verify that our application is correct. So what does it look like to declare a custom component? Now that we've seen all the parts, how does this all come together? So first, we have a factory. And this is the function. This is a function variable that constructs UI props instances and gives us instances of those builders. And this is the entry point to the component. This is what your consumers are going to use when they're rendering them. And then we have our UI props class, which is the builder, and it's also a map. So it has the type getters and setters for convenience, but it also can be used wherever a map can be used. So what's nice about this is it makes these props classes backwards compatible with all the React Dart APIs that take map, because it is a map. And then finally, we have the component, which contains all of the rendering and lifecycle logic. And it also has typed access to props and state. So just like you use those setters to set the props when you're consuming the component, you can use the getters to read them within the component. And so you'll see that we have these annotations on all of these classes, and that's what the transformer uses as hooks to define the component declaration and to do that code generation. And so you can see that the UI props class is used as generic parameters in UI factory and UI component, and that's what allows like the component-specific typing to be analyzed properly. And so from that, the transformer first takes the UI props class and synthesizes all those getters and setters. Then after that, it does some wiring up of the UI props class to the factory and the component. There's a bunch of stuff that needs to happen under the hood. You have to register a component with the React Dart factory. There's also some weird stuff around constructors that we didn't want to put on consumers. So basically, to minimize boilerplate, we just kept the UI props, UI factory, and UI component declaration as is, and had the transformer do all the heavy lifting. And so there's a big section in our README that goes into more detail about how this actually works. And I wish I could get into it in this presentation, but I don't have time. So if you're interested, definitely check it out. I think it's really cool. I'm biased, though, because I'm the one who wrote it. So, but anyway, for now, just know that you add the overreact transformer to your pub spec, and then all of the components that you declare will get transformed under the hood and on the fly too. The great thing about pub transformers. So now that we've seen how to build a component, let's actually do it. Let's build a component. So what I want to build is a counter component, because I think computers can probably count better than I can. So this counter component is going to be a button that when I click on it, it's going to increment the count. You get the gist of it. And so first, I'm going to add some rendering logic to my component. I'm going to add a container and then render a button and just wire up an on-click handler that I'll stub out for now. And you can see it does what we expect. It's a button that doesn't do anything. So now let's add some props to make this component a little bit more configurable. So I'm going to add props to allow the consumer to specify the initial count, the initial state that the component will start counting at, and also the amount that it'll count by when you click the button. So I've just declared these as fields in the props class, and I've typed them as ints. And then in the component, I can take the props and I can read them and do props.increment amount and string interpolate that in my button text. And because, again, we've used counter props as a generic parameter, we get typed access to props. So anything that's declared in props, we can just do dot and it'll autocomplete and analyze properly. So if we pass in a initial count of 1, then it renders as expected. Now, since we want the component to update itself, we need to declare some state. So in this case, I've made a new state class and swapped out the base class from UI component to UI stateful component. This allows us to add this generic parameter so we get typed access to this state. And so, I went too fast. And so in the state, we're going to declare a current count field, and that'll be a state key value pair that keeps track of the current count of the button. So now we can consume that. You'll see in the container, we're string interpolating state.currentCount, just like we did with props, so we can display to the user what the current count is. Then also, we are setting up the initial state of the component. So we're initializing the current count state to the initial count specified in props. And you'll see that I'm using this new state method, and this is a convenience method that'll just give you a new instance of counter state. So it gives you like basically an empty map that you can cascade key value pairs on, and then you can return that to get initial state, and React will wire up that initial state properly. And finally, let's do the fun stuff and mutate the state. In React, the way that you mutate state is that you pass in a map into setState, and it merges that map on the existing state, overriding any values. So in this case, we're going to call setState, create a new map, and set the count on it to the current count plus the increment. And so that new count key value pair is going to overwrite the existing one, and then the component is going to re-render with updated state. And after that, we're all done. Let's see if it works. And it works. Awesome. Woo! And so you'll see that we've set initial count to 0 and increment to 1. But we can also configure those, and it'll work as expected. For the sake of this demo, I didn't include it, but you can add default values for these props so that you don't have to specify them anytime. They'll fall back to default values, but for the sake of simplicity, I just left that out. So some other cool things relating to Overreact. Overreact has a bunch of other cool features besides component declaration. We've got CSS class name building with like a very Dart-like API, similar to the class names utility in bundled with React.js, but it's got one more feature that it doesn't have. We got type checking. That's something that wasn't possible in React Dart, but is possible in JavaScript, being able to tell whether a VDOM instance is a type of a certain component. That's useful for conditionally rendering passed-in children, and also generic callback chaining. Something I also wanted to call out is testing. With React Dart, there is a wrapper currently for React Test Utils, which is a test utility suite bundled with React that allows you to simulate events and query for different components and get data about them. So that all works with React Dart and with Overreact. But we do have a set of Overreact test utilities that we've made to make that process a little bit easier and yeah, add some stuff that React Test Utils doesn't have. So know that that's coming soon, but in the meantime, you can still test with this using just React Dart Test Utils. So I couldn't come all this way to Germany without mentioning some other Workiva packages, but these really are relevant to React. One of them is wflux, which implements the unidirectional data flow model that was inspired by Flux and Reflux.js. So we use this a lot internally to manage the data flow within our apps, and it integrates great with React. There's actually a Flux UI component in React that automatically declares actions in store, and when the store triggers, it'll automatically re-render your component, so that's very well integrated. We also use Dart Dev to run our tests and coverage, and that makes it easier. We use that in React. And there's a bunch more packages at workiva.github.io. We love to open source stuff when we can, give back to the community, so expect to see more from that, more at that site. So again, here's the link to the docs, beautiful doc site, our repo. And if you have any questions about any of this, feel free to come grab me after this talk or open up a GitHub issue. We're very responsive. You know, if there's something that you don't like, or if you have an idea for an improvement, a bug, just file a GitHub issue. We'll be really responsive on that. And if you want a direct line, there's my email or my team's email. And yeah, give React and Dart a shot. Thank you.